Good day, everyone. Today we will be talking about type of variables in research, but specifically we will be focusing on the quantitative research, experimental and non-experimental. And take note that what we are going to talk are just the basic variables. But first, let's define variable. What is variable? So variable is a measure or measurable characteristic that varies. Again, a measurable characteristic that varies. It may change from group to group, person to person, or even within one person over time. Let's say, for example, from person to person, your height is a variable. That is a measurable characteristic. You can get a tape measure or even a meter stick to measure that one. So that is a very measurable characteristic. And it varies from person to person. One may have 5 feet 2 inches. One may have 6 feet height. So that is one of the examples of variable from person to person. But there is also a variable, or there are variables that is changing in within one person. Let's say, for example, your salary. If you are working and your salary, let's say in your first year you got, let's say, 15,000, and then you were promoted, and then on the next year you got 20,000. So since that is in numbers, that is a measurable characteristic. Your salary is a measurable characteristic, and it is varied, or it's changing over time. Now let's proceed to the basic variables that we are going to talk about. And those are independent variables, moderating variables, and control variables. Before we go to example, of course, let us define each of the variables. Independent variable is the variable that is presumed to influence the other variable. So it is the presumed cause, whereas the dependent variable is the presumed effect. Let's say, for example, that you are going to water the plants. You can manipulate the amount of water of plants, and it is the cause of the, let's say, growth of plants. Water is the cause of the growth of plant, and the plant is the one that is receiving the effect. Water as the cause is the independent variable. In other words, independent variables are those variables that the researcher has control over. You can control these variables, and this control may involve manipulating existing variables, while the dependent variables show the effect of manipulating or introducing the independent variables. Let's say, for example, you drank coffee and then you cannot sleep. Drinking coffee is the cause of not sleeping, and therefore drinking coffee is the independent variables, while the dependent variable is the sleep, or since you cannot sleep and it receives the effect, or receives the effect of the independent variables, it is the dependent variable. Next is the moderator variables. It is the variable that affects the relationship between the independent and the dependent variable. Another way to think about is to think about moderator variable. It is the one that influences the strength of a relationship between two other variables, and yes, that's it. Now, control variables are the variables that are not measured in a particular study, which must be held constant, neutralized, balanced, or eliminated so they will not have a biasing effect on the other variables. However, the definition of control variable when it comes to experimental is different, because it is measured as a form of standard between your other variable. Let's explain that further with a specific example. Okay, supposedly you are interested in answering how drinking coffee affects memory. Let's say uh, you've noticed some of the experiences that when you drink coffee, you seem to be more smart or smarter, and then you're like brighter or something like that. So let's have the independent variable, the cause, and the dependent variable. So between the two, drinking coffee affects memory. Drinking coffee and memory. The one that affects memory is the independent variable, and therefore drinking coffee is the independent variable. When you drink coffee, it affects the memory, and therefore memory is the dependent variable. Therefore, in this case, memory is dependent upon drinking coffee. That's why it's called dependent variables. So drinking coffee affects memory. So independent variable can be manipulated, or somehow you can intervene. Let's say, for example, you want to test that one. See, you drank 3 cups of coffee, and then you studied, and then you measured, let's say, your memory about how much of the, let's say, amount of materials you've read you still remembered or you've memorized. And then the next day you can still um, manipulate drinking coffee. Let's say you just drank 1 coffee or 1 cup of coffee, and then you memorize again and see the differences. Now, you cannot somehow control your memory, but you can control drinking coffee and see if how does drinking coffee affects your memory. Now, the moderating variable is here. Let's say, for example, remember, this determines the strength of relationship between the independent variable and the dependent variable. Let's say, for example, most of the common examples of moderating variables are, let's say, for example, one example is sex or gender. Now, in this case, even if you say that you want to test drinking coffee and how it affects the memory. But then your test subject, let us say, for example, a random number of people, and that includes gender. But there are studies that states that gender, or based on gender, there are gender, let's say, for example, just example, not to be gender biased or sexist in a way, that the males are more, let's say, intellectually inclined towards memorizing things than females. So gender may play a role on the effect of drinking coffee to memory. So gender, or the moderating variable, strengthens the relationship of the independent variable to the dependent variable. So in this case, even if you say you just wanted to study the IV and the DV, or the independent variable and the dependent variable, you cannot neglect the possibility of the gender as moderating variable affecting the result of the drinking coffee, or the independent variable, to memory, or the dependent variable. In experimental research, specifically in the pure experimental research, we have other forms of variables, and we can call them the scientific experimental variables, or groups. And this is divided into two main groups, or variables. That is the experimental group or variable, or treatment and control group, which is divided into two, the negative control and the positive control. Remember, these are just the basics. Okay, so the experimental group or treatment is the one that you are manipulating, or the proposed, let's say, treatment in your study. While the control group is divided into negative control and positive control. The negative control is presumed to have no effect. The positive control is presumed to have effect, or known to have an effect. Okay, let's have another example of that. Okay, let's say this is your research. The effect of chicken manure to growth of plant. Let's just say you don't know about this, and you are thinking of having a theory that maybe chicken manure can help the growth of plant. So the very basic of IVDV, or independent variable and dependent variable, is that your independent variable, or the one that you are going to manipulate, is of course the one that will cause the growth of plant, is the chicken manure. And the dependent variables, or the one that will receive the effect, is the growth of plant. So this is the very basic form. However, if you are just going to test if chicken manure will somehow affect the growth of plant, you will not, your data will not be reliable because you don't have a standard unit of measure, standard measurement, or you don't have a standard to which you are going to compare it to. Let's say, for example, of course, the plant will always grow as long as there's soil in it, of course. And therefore, when you say that the chicken manure really helped the growth of plant, so let me ask you the question, what is your basis and where did you compare your information or the data that you gathered to say that your chicken manure actually helped the growth of plants, since all of the plants grow? And therefore, to answer that and somehow not do that mistake, you are going to divide your IV, independent variable, or the variable in your scientific experiment, into experimental treatment or experimental positive control and negative control. Remember, experimental control is the one that you are proposing or the one that you are testing, and what we are testing is the chicken manure. Now, the positive control is the type of treatment that already has an effect that you really know that will increase the growth of plant. And of course, commercial fertilizers. Since commercial fertilizers are known to actually increase or hasten, let's say, for example, yeah, hasten the or increase the growth of plant. And the negative control, remember, negative control has no effect, or somehow you're not going to do anything about it, or you have nothing to put in it. But sometimes we use water, because water, it's not either experimental or chicken manure. It's not also commercial fertilizer, because plant needs water and no water is normal. Remember, experimental is the one that you are proposing or testing. Positive control is the one or the treatment that you know and actually proven to have an effect on your dependent variable, which is the plant. And then negative control is, let's say, the basis of just nothing, or in this case, just water. So we also have other control variables. When we say other control variables, those that must be kept constant. You cannot change them. When you want to know if chicken manure really affects the growth of plant, you have to keep the soil constant, the amount of soil constant, or the same on all of this testing or the experiment, the type of soil that you are going to use, the amount of water, the type of plant that you are going to test, the type of plant that you are going to test, the chicken manure, the commercial fertilizer, and the water. Also, the amount of sunlight, the environment that they have, and all other things. They must be controlled, or they must be kept constant, so that you will really know that it is only the chicken manure, the fertilizer, and the water that you are testing, and not other things that might affect the growth of plant. Now that you have the positive control and negative control, when you get the data of both, of all the experimental positive and negative, you can now compare against each one of these, or even all of it, so that you will really say that experimental control, the experimental group or the chicken manure increased the growth of plant, because when compared to the negative control or water, let's say, for example, the plant that you put the chicken manure with actually is taller, or let's say grow faster than the those with negative control. But it could also be that your experimental control is better than the positive control. The experimental group is better than the positive control. But there are times, of course, since commercialized fertilizer or positive control is known to have an effect, and therefore, sometimes experimental group is less than the positive control. And that is all right, as long as there is an effect. That means your research has good result. Okay? So those are the basic variables that we have. To recap, we have the independent variable, the dependent variable, moderating variable, control variables. In the scientific experimental, we have this experimental group, positive control and negative control. So that's it for today. Let's proceed on our next lesson.